Which choice best describes data from the table supports the student's argument? Native to Latin America, the cane toad was introduced to Australia in the 1930s. In recent decades, tadpoles in the Australian population have been shown to consume eggs of their own species. A 2022 study showed that when presented with cane toad eggs, as well as eggs of native Australian amphibians, cane toad tadpoles disproportionately consumed eggs of their own species. This behavior results from their attraction to bufadienolide, a chemical produced by the eggs of cane toads, but not by the eggs of native amphibians. However, using data from this study, a student wishes to argue that the presence of bufadienolide doesn't entirely explain the cane toad tadpole's preference for certain eggs over others. So once more, the student's argument here is that the presence of bufadienolide doesn't entirely explain the cane toad tadpole's preference for certain eggs over others. So looking at this table, there are 4 different columns. The first is the names of different amphibian species, where there are 5 different species: the little red tree frog, cane toad, short-footed frog, striped burrowing frog, and the dainty green tree frog. The second column shows the percentage of eggs eaten by cane toad tadpoles, and this varies from 1 to 90%. Then the third column describes if these frog types are native to Australia, and the fourth is whether bufadienolide is present in these eggs. So looking at the answer choices, option choice A says the tadpoles consumed a higher percentage of the striped burrowing frog eggs than they did of the eggs of the dainty green tree frog. So looking at this table, the striped burrowing frog eggs is right here, and 10% of these eggs were eaten by the cane toad tadpoles, and for the dainty green tree frog, 1% of these eggs were eaten by the cane toads. So A seems to be the correct answer because it properly supports the student's argument, which is that the presence of bufadienolide doesn't entirely explain the cane toad tadpole's preference for certain eggs over others. And comparing these two frogs' consumption rates can prove this, because neither of these produces bufadienolide, yet 10% of the striped burrowing frog's eggs were eaten, whereas only 1% of the dainty green frog's eggs were eaten. So A seems to be the correct answer. B. The tadpoles left a certain percentage of the eggs of each of the 5 species unharmed, thus ultimately allowing them to hatch. This is incorrect because this doesn't support the student's argument. This doesn't really show how the presence of bufadienolide doesn't entirely explain the cane toad tadpole's preference for certain eggs over others. Therefore, B is incorrect. C. The tadpoles consumed a lower percentage of the short-footed eggs than they did of the eggs of their own species. So, looking at the table, it's the short-footed frog, only 7% of the eggs were eaten, and for their own species, 90% were eaten. So C is incorrect because this doesn't support the student's argument. This goes against the argument because the student's argument is that the presence of bufadienolide doesn't entirely explain the cane toad tadpole's preference for certain eggs over others. And this goes against it because it shows that the presence of bufadienolide causes the cane toads to eat those eggs specifically. And therefore C is incorrect. D. Tadpoles consume the same percentage of the dainty green tree frog eggs as they did of the little red tree frog eggs. This is incorrect because although the data is accurate as compared to the table, this doesn't support the argument by the student because this doesn't show how the presence of bufadienolide doesn't entirely explain the cane toad tadpole's preference for certain eggs over others. Because this data shows that if there is no bufadienolide, they consume very little of these type of eggs, regardless of the type of amphibian species. Therefore, D is incorrect, and the correct answer is A.